Hi, my name is Bill Kinney, and this is my 83rd video on problem solving for Actuarial Exam 2 in Financial Math. We've mostly been doing problems from the 6th edition of the Mathematics of Investment and Credit by Samuel Broverman, and that continues in this video. Problem 3.3.1, find payments to a sinking fund to pay off a loan and construct a table for the values of these things, the outstanding balance, the principal reduction, and the interest values. This video is going to be kind of long because I'm going to separate it into two parts. The first part where I solve the first part by hand, the payment to the sinking fund. Actually, it's not quite the payment to the sinking fund, but it's related to it. And the second part where I'm going to show you how to make this table of values in something called a spreadsheet, which I haven't shown you yet, but every actuary should know how to use a spreadsheet. So it's going to be kind of long, but it'll definitely be worth it, I think. I should warn you that this sinking fund problem is not a typical sinking fund problem as well, so there's a little wrinkle in it that you'll see right now. So here's the problem statement. You've got a loan of $100,000. It's going to be paid back in kind of a strange way. There's going to be annual interest rates of interest payments of 12% per year for 10 years. So that's going to be 12% of $100,000 is $12,000. In addition, from the borrower, the lender will receive a lump sum repayment of the entire principal along with the 10th interest payment at the very end of 10 years. The borrower is doing the paying the annual interest, and accumulating, here's where the sinking fund idea comes in, accumulating the $100,000 that's going to be used to pay off the loan by annual deposits into some other account, the sinking fund, at 8%. There's your sinking fund. Okay, so the sinking fund idea is just it's another fund, another investment that can be used to accumulate money to pay off a loan. It's kind of strange. You might wonder why you would pay it back this way, but evidently it happens sometimes. The borrower wishes to schedule deposits into the sinking fund in, okay, here's the atypical way. It's not going to be level deposits. It's going to be such that his total annual outlay, meaning deposit into the sinking fund plus the interest payments, is X for each of the first 5 years and 2X for each of the final 5 years. The goal of the first part of this video is to find X. That's the part we're doing by hand. We're also going to construct a table in the second part giving these values. And the way we do this is not in the ordinary kind of way because of the strange way this is being paid back. The way we're going to keep track of these quantities, the outstanding balance, principal repaid, and net interest paid, is different. So you're going to want to really focus on the things that I say when I'm talking you through the spreadsheet and how to use that. But let's go ahead and start now with the first part of the problem. Let's solve for X. So you've got the loan repayment that can be visualized as follows. Timeline, time is going to be in years. You are paying just interest for the first 9 years. 12,000, 12% of 100,000. Let me write that as 12K. So the K here stands for 1,000. 12K or 12,000 for each of the first 9 years. At the end of 10 years, at time 10, it's going to be that final interest payment plus the loan amount of 100,000. So again, K just stands for 1,000. All right, so that's how the loan repayment scheme looks. How about the sinking fund? Do it on a separate number line. And I think I may want to include all the numbers here from 0 through 10, since the amount is going to change from time 5 to time 6. It's not X that's being deposited for the first 5 years and then 2X. X is the total annual outlay for those first 5 years. Again, that includes sinking fund deposit plus loan repayment. Therefore, the deposit into the sinking fund at time 1, for example, is X minus 12,000. Same at time 2, X minus 12,000. So that's one wrinkle here, is we're not actually solving for the deposits into the sinking fund. X represents the total annual outlay for each of the first 5 years. For the final 5 years, the total annual outlay is 2X into the sinking fund, so it would be 2X. 2X is the total annual outlay, so into the sinking fund we're going to have 2X minus 12,000. 2X minus 12,000. So the X is the unknown we want to solve for, and the K just stands for 1,000. Now you might wonder, at time 10, why bother making a final deposit into the sinking fund? And yeah, you really wouldn't have to in real life, but to make the math easier, and then based on the assumption and the assumptions of the problem, I believe we do want to put a 2x minus 12,000 here. And by subtracting the 12,000 there, you're already taking care of that 12,000 here. So you really do get these two different kinds of payments into the sinking fund for the first 5 years and for the last 5 years. And we do want the future or accumulated value of all these payments at time 10 to be 100,000, not 100 plus 12,000. You've already taken care of that 12,000 by subtracting it here. All right, so now we solve for x. What's your equation of value? You've got your payments of x minus 12,000. Let me go ahead and dispense with the k right now. X minus 12,000, if we find the future value of that at time 5, we'd multiply it by S5.08. But we want to get to time 10, so we need to multiply that by 1.08 to the 5th. We need to promote that value at time 5 to time 10. Then we have the last 5 payments into the sinking fund of 2x minus 12,000. And that's a future value, so it's 5 payments with 8% interest rate for the sinking fund, so it's S5.08. That's got to pay off the loan balance of 100,000. All right, this is your equation of value to solve for x. Let's go ahead and use the calculator now. All right, let's find S5 first, 1.08. This is a formula sheet you should have memorized. Raise that to the 5th power, subtract 1, divide by 0.08. 5.86660096. Let's store that in register 0, store 0. I need to multiply that by 1.08 to the 5th as well. 1.08 to the 5th power is this, times what's in register 0. This number right here, you can see is 8.6199615. Let's store that in register 1. I need to multiply both of those numbers by 12,000. So let's do this one first. The 8. Let's keep the order the same. Let's do this one first. So 5.86660096 times 12,000 is this. Let's store that in register 2. I think I'll just do this. I'll put a 2 like that. I also need to multiply what's in register 0 by 2 because of the 2x there. So let's see, register 0 times 2 is this. How should I denote that? This times this is in register 3. Store in register 3. And finally, I need what's in register 1 times 12,000. Call 1 times 12,000. That will be what I'll store in a register 4. Store 4. All right, okay, so get my equation of value now. I need to, the coefficient of x is going to be the sum of what's in register 3 and 4. No, excuse me, what's in register 3 plus what's in register 1, because that gets multiplied by 1 here. So let's see, let's just write that out. What's in register 3 plus what's in register 1. This is the coefficient of x. Let's go ahead and just write that down, and I won't bother storing that. 20.353. I always like keeping a lot of decimal places just to play it safe. That gets multiplied by x. On the right, I'm going to have 100,000 plus the sum of what's in register 2 and what's in register 4. So let's go register 2 plus register 4 plus 100,000. 273,838.7496. We're almost done. X therefore is, divide this by 20.353, 16343. X is 13,454. To the nearest cent, say, would be 36. But let's go ahead and put all the decimals, and I'm going to put these decimals in the spreadsheet as well. 35812. There's the first part of the problem. Now I'm going to go on to a spreadsheet. All right, we are now on to the second part of video number 83, where we are using what you see here, what's called a spreadsheet. This is an Excel spreadsheet, Microsoft product. You can also use a Google Docs spreadsheet, for example. They work pretty much in the same way to ultimately make a table of values for interest paids, principal reductions, and outstanding balances for our loan, where what we really are after actually is our net debt, so to speak. You might think of it as the loan minus the sinking fund. We are repaying back this loan in this strange way of only paying interest for the first 9 years, and then in the 10th year, paying interest plus the entire principal. We are building up the principal with a sinking fund. And yeah, we want to think of net debt, not what's actually in the loan amount balance for what we make in the table here. How do you use a spreadsheet? Well, one thing you can do in these cells here, these boxes, is you can type in words like I have. You can also type in numbers, like, for example, in this cell right here, cell B3, I can type in 100,000. That's the loan amount. Enter it. I can also, in this next cell, B4 is its address, its cell reference, I can type in the effective annual loan rate, which was 12%. I'll type it in as a 0.12. Then in this cell, B5, I can type in the annual interest payment on the loan that goes toward the lender, 12,000, which is the product of these two things. I could type that as either equals 1,000 times 0.12, or what's better is to use cell references, to use a formula, so to speak. Use the cell references for those numbers, B3 and B4, to do that multiplication. Why is that a good idea? For a number of reasons. One reason is that it allows you to make changes if you need to. I could change this 100,000 to a 200,000 and everything gets updated correctly. You see this is now 24,000 instead of 12,000. It's 12% of 200,000 instead. Let's go back to the original numbers now. So that's one benefit. Another benefit we're going to see here in a minute is you can copy and paste formulas, and that is definitely a good idea to make tables of values. But before we do that, let's remind ourselves what these things are. X was what we solved for in the first part of the video. That was the total annual outlay that the borrower was paying for the first 5 years. We found that to be 13,454.35812. I'm going to go ahead and include lots of decimal places here at first, though in the tables that I make I'm going to round to the nearest cent, so to speak. I'm going to use currency. But we're going to keep more decimal values in the spreadsheet's memory, so to speak, by going ahead and entering more decimals here to try to guarantee more accuracy. What were the first 5 deposits to the sinking fund? Well, X again was the first 5 annual outlays, of which 12,000 had to go toward interest. So the first 5 deposits into the sinking fund was 13,454 minus 12,000. With a formula in cell references, I can do that as equals B6 minus B5. I can also, by the way, click on those cells and the cell reference shows up like this. Okay? You do need to put the equal sign in there. The equals is sort of the signal that you're going to do math. You're going to put a formula into this. There we go. And the last 5 sinking fund deposits at times 6, 7, 8, 9, and 10. Remember, the total annual outlay for those last 5 years was 2x. Therefore, 2 times x minus 12,000 is the last 5 deposits into the sinking fund, 14,908.7. What was the sinking fund interest rate? It was 8%. I'll type a 0.08 into there. All right, now things get even more fun, I think, with these spreadsheets. We're going to use the magic of copy and paste here. Let me go ahead and put the time in years. Starting, say, with time 0 is fine, even though we don't have any money in there at time 0. One fun thing to do here with copying and pasting cell formulas is to get a 1 here, not by typing a 1, but instead typing equals B13 plus 1, a formula that's going to take what's in cell B13 and add 1 to it. And if I now copy and paste this formula from cell B14 into the next cell below it, cell B15, it gets updated in just the way you'd want to. I can copy and paste either by doing a Control-C, click Control-V, or if you prefer, you can also just highlight this cell, click the lower right corner and drag it down. It has become a 2 now, and that's good. Take a look at the formula that's up here. It's a little hard to see. Well, I clicked on it and it comes back up here down there. I never typed this. Into cell B15, I never typed equals B14 plus 1. What I did was in cell B14, I typed equals B13 plus 1. And I copied and pasted that formula, and the B13 got changed to a B14 in this cell, cell B15. And that's just what you want here. And that's going to make it so that all these numbers are one more than the previous number until we get to the last one at 10. You can see what's in that cell is the formula equals B22 plus 1, which is going to be 9 plus 1, which is 10, just like you want. Sometimes you don't want that copy and paste to happen in that exact same kind of way, but there is a way around that. I'll show you that in a minute. All right, for the sinking fund, IT represents interest earned, DT represents deposit at time T, OBT represents outstanding balance at time T. We don't make our first deposit until time 1. So let me just go ahead and put a 0 there for the outstanding balance at time 0. But let me go ahead and now in this row, row 14 here, in these 3 cells, let me go ahead and type formulas that would be appropriate formulas to copy and paste downward, at least through time 5. Maybe not after that because the deposits change. What interest is earned at time 1? That would be the interest earned on the outstanding balance at time 0. Well, it's going to be the outstanding balance at time 0, which is 0, times the effective annual sinking fund rate. E13 times B9. But careful here, the E13 should be updated as a copy and paste downward to E14, then E15, then E16, etc. But this B9, I want to stay the same. I don't want that to get updated to B10 and B11 and B12 because those are not numbers even. So I need some workaround. I could just type 0.08 here, but it's better to use dollar signs. I'm going to type $B, $9. Technically, I only need the second dollar sign, but to play it safe, I'm going to put 2 dollar signs. The first dollar sign really fixes the column to be column B, and the second dollar sign fixes the row to be row 9. As I copy and paste this downward or to the right or whatever, the B9 would stay the same. The B stays the same because of the dollar in front of the B. The 9 stays the same because of the dollar in front of the 9. Because I'm going to copy and paste downward, I really only need the second one, but don't worry about that. Just to play it safe, let's use both. What's the deposit? It's what's in B7, and as I copy and paste that down through at least time 5, I want that to stay the same. $B, $7. 1454.35812. And my outstanding balance now at time 1 is going to be the previous outstanding balance plus the interest earned plus the deposit made equals E13 plus C14 plus D14. I'm now ready to copy and paste this stuff down. Actually, let me also go ahead and change it to currency right now. So I'm going to go up here and change this to currency. Use dollars. I can now copy and paste these down. It's going to round to the nearest cent based on more decimal places that I have up there. I'm just going to highlight those things and click and drag the lower right corner. That will do a copy and paste. And oh, I went too far. I realized something looked wrong there. That's only for the first 5 years. Starting at time 6, the deposit changes. So this deposit at time 6 now becomes what's in cell B8 now instead of cell B7. So I do $B, $8. If you see something like that, it means you need to make your cell a bit bigger because it's not enough room. So widen the cell. There we go. Copy and paste this down, and now I can copy and paste all of these down to time 10. And at time 10, once I open it further, I see magically $100,000 on the dot to pay back my loan. My sinking fund has accumulated to $100,000, just like I wanted it to. All right, so that's kind of cool to see that happen. You can see your sinking fund values go up over time. Now we want to do what the goal of the problem is, to find IT, PRT, and OBT for the loan, or rather, loan minus the sinking fund, so to speak. This is a little tricky. I'm going to go ahead and copy and paste the times over. So I did a Control-C and a Control-V there. I could also do, of course, copy and paste from up there. The outstanding balance at time 0 is the loan amount from cell B3. I don't want to use dollar signs there, and in fact, I'm not going to copy and paste this formula downward. I'll just type equals B3, and that is a dollar amount. I'll wait a second here to change it to dollars. All right, here we get a little tricky. What is the interest that is paid, so to speak, at time 1? It would really be the interest that you pay on the loan minus the interest that you earn at time 1. Now, the interest earned at time 1 is 0, but don't worry about that. It's not going to be 0 for these other ones. So I really want the interest on the loan, which comes from the outstanding balance on the loan, times the effective annual loan rate, which is in cell B4, use dollar signs, minus the interest earned on the sinking fund at that given time. So minus C14 here. So it's sort of net interest owed, interest that you owe minus interest that you earn. That's one tricky thing. It's going to be 12,000 here in this case, but it will go down over time. Another tricky thing is the principal reduction. I hope you remember that in general, the principal reduction at time t is the difference in the outstanding balance on the loan. That can also be thought of in this case, since this outstanding balance for the loan company effectively stays constant, as the difference on the outstanding balances of your sinking fund. So I can do equals E14 minus E13 here in cell I14. And yeah, don't use dollar signs. You're going to want to continue looking at differences on the outstanding balance of the sinking fund and think of that as principal reductions, just like you do when your actual outstanding balance for the loan goes down. For the loan company, it's, they don't necessarily even know that you're thinking about using a sinking fund here. They just want their interest every year, their $12,000, and their outstanding balance from their perspective doesn't go down at all. But from your perspective, you want to think of it as this difference here. And now for the new outstanding balance on the loan as loan minus sinking fund, take the previous outstanding balance and subtract the principal reduction right there. And now these are all dollar amounts. So now, when I copy and paste these formulas downward, I should get a balance of 0 down here. Okay? Something kind of funny does happen right there that we will see, but it's okay. If I've done this right, I should get a balance of 0. Click and drag this down, copy and paste. And yes, I do get a balance of 0. You can ignore that minus sign. And yeah, something interesting did happen here at time 10. I have a negative interest paid. The reason is because I earned more in interest on the sinking fund than I had to pay on this outstanding balance from the loan, the net debt outstanding balance on the loan. So that's why this is negative. It's not a big deal. Don't worry about the minus sign there. It is 0 for the final outstanding balance. So this table that you see right here is the final part, the final answer to the problem that we did, 3.3.1 from Broverman.